Okay, so this video looks at the basics of complex numbers, okay? So we are going to look at adding complex numbers, subtracting complex numbers, and multiplying complex numbers. A complex number, first of all, is a number that consists of a real and an imaginary part, okay? So 4 plus 3i is a classic example of a complex number. It has a real part, the 4, that's a real number. And it has what we call an imaginary number. And of course, you know it's an imaginary number because they use the I. Now, where do imaginary numbers come from? Well, let's come over here to discuss imaginary numbers. So, imaginary numbers in maths come from the idea that when you square root a negative, we have a little bit of a problem. So if you look at the calculator, for example, and you try and put square root of -9 and you press equals, it comes up as a math error, all right? Because technically, you see, there's no number that could be multiplied by itself to give you a -9. Because if you had, for example, a -3 by a -3, well, that would give you a +9 because a minus by a minus is a plus. The only way you'd get a -9 if one of them was minus and one of them was plus. But of course, the whole idea with square rooting is trying to find two numbers that are the same that will multiply to make the number, okay? So the question in mathematics is then, how do we deal with a square root of a negative? And the way we deal with the square root of a negative is we consider it to be the square root of 9 multiplied by the square root of -1. Okay, because the square root of 9 times the square root of -1 is the same thing as the square root of -9. And now what we do, instead of the square root of -1, we replace that with I. So that becomes, square root of 9, of course, is 3, and the square root of -1 is where the I comes from. So the key piece of information that we need to remember is that the square root of a -1 is always what we put equal to I. And then following on from that then, if you square both of those sides, you're going to get I squared on that side, and squaring the square root of -1 is n minus 1. So that's the other thing that you have to make sure that you are super familiar with, that if I is equal to the square root of -1, then I squared is equal to -1. So those two things you need to know really, really well. I is equal to the square root of -1, therefore I squared is equal to -1. Okay, so just to get used to the idea of imaginary numbers, let's have a little look at these numbers here that will produce some imaginary numbers. Press pause if you've got an idea what each of these will be equal to, based on the example that we just had a little look at there with the square root of -9. Otherwise, listen on and we'll go through each of these thoroughly. So, the square root of -25 is the same as the square root of 25 times the square root of -1. Okay? And of course, the square root of 25 is 5. And the square root of -1, well, that's what we always put as I. So that is equal to that. Square root of -1 is the same as I, which means that the square root of -25 then is equal to 5i. So the square root of -100, well, that's the same as the square root of 100 times the square root of -1. And of course, the square root of -1 is what we write down as I, and the square root of 100 is 10, so it is going to be 10i. Square root of -64, well, that's the same as the square root of 64 times the square root of -1. Square root of 64 is, of course, 8. Square root of -1 is, of course, I. Square root of minus 49 is the same as the square root of 49 by the square root of minus 1. Square root of 49 is of course 7, and the square root of minus 1 is what we use as I. Square root of minus 1 is of course I. And this is the same as this, which of course is 11I, and this one is the same as this, which of course is 4I. Okay, so as I said already, this video is all about the basics of complex numbers. So the first thing we're going to look at is adding and subtracting with complex numbers. Alright, so let's jump straight into an example. So a complex number, remember, consists of a real and an imaginary part. Okay, so there we go. That's a complex number. So let's say we're asked to add these two together. Okay, well, what we do with something like this, so you've got this complex number, and we need to add to this complex number. Well, the thing with complex numbers, it's a little bit like algebra in the sense that the rule of thumb with algebra when adding together, the thing that you always need to remember is that you can only add together the things that are the same. Well, it's true with complex numbers as well. You can only add together the things that are the same. In other words, you can only add the real parts with the real parts and the imaginary with the imaginary. Now, just make sure you know what sign is there. So just to make that clear, I'm going to include that plus there because, of course, it is a positive 7 that I need to add on, and that's important to make sure you realize. The sign to the left is really important that you are clear on what it is, because obviously it's going to make a huge difference to the result. So we have a 3 and a positive 7. Adding those together is a 10. And the 2i, positive 2i, take away 6i, 2 take away 6 in other words. If you need to do that little number work on the calculator, by all means do, but don't forget your I at the end. A plus 2i minus 6i is of course minus 4i. So when you add these two complex numbers, you can add the real parts together, add the imaginary parts together, and that's the answer you get. Okay, so let's take a look at this question here. This question has the two complex numbers labelled, Z1 and Z2. Now they often do this. They'll just put a name on the complex number or label it. So we first of all are being asked to add these two complex numbers together, Z1 and Z2, so this one added to this one. And then we're being asked to subtract the two complex numbers. So the first thing we're going to do is we are going to add the two complex numbers. So it is important to keep brackets around them as we sub in for the Z1 and sub in for the Z2, as always with any substitution. Keep brackets around what you sub in. And then, of course, we can evaluate what we have. It's going to become extremely important when it comes to the subtraction, as we'll see in a minute. But here, when we're adding together 5 minus 6i, we're adding it to minus 2 plus 4i. It is going to be just the same as 5 minus 6i. And, of course, adding together a minus 2 is just going to be like taking away the 2. And adding together the 4i is just going to be adding that 4i. Now remember, your rule of thumb, of course, is you must add together the real with the real. So that's a positive 5, but that's a negative 2. So make sure you're including that sign to the left when you're considering that. And the imaginary with the imaginary. So here we go. We're going to have the imaginary, which of course is a minus 6i, and add it to plus 4i. So let's do that. 5 take away 2, of course, is 3. And minus 6i plus 4i. Again, do the number work on the calculator if you need to double check it. People always make mistakes with negative numbers, so I prefer you to be accurate and check it on the calculator than to get it wrong. Minus 6 add 4. Don't forget your I, of course, is minus 2i. So now let's subtract these. So now I have 5 minus 6i, sub in for the z1, keep brackets around it, minus, and the z2 of course is minus 2 plus 4i. Now, as I said, here's where it's really important that you have those brackets, because when I come to subtract the minus 2, we're going to end up with a minus 2, or subtracting a negative, remember, has the same effect as adding. So you're going to want to be very careful as the effect that that minus has on that and that. So let's take a look. So we have 5, obviously, minus 6i, minus 2, which is the same as adding 2, and a minus a positive 4i is just like taking away the 4i, okay? So just watch out for that. Minus 2 becomes plus 2, and taking away a positive 4i is just taking away 4i. So now we have different signs here, so be careful. So adding together the real with the real, now we have 5 plus 2. Make sure you consider and include that sign to the left when you're doing your additions and subtractions. And we have a minus 6i, the imaginary with the imaginary now, minus 4i. Right, so let's work that out. So we have 5 plus 2, which of course is 7, and minus 6i minus 4i is a minus 10i. So the important point here to remember, and the important note to take down, is that if you're adding or subtracting with complex numbers, the thing to remember is to add or subtract the real with the real and the imaginary with the imaginary. Okay, so now let's take a look at multiplication with complex numbers. Now, similar to adding and subtracting with complex numbers, we could see the similarities with adding and subtracting with algebra. And multiplication with complex numbers will also be very, very similar to multiplication with algebra. There's just one little thing that you need to watch out for. So let's jump straight into an example and we can see how this crops up, okay? So let's take the example 4 times 3 plus 6i. Well, let's say you have these brackets, and brackets always implies times, and we're going to multiply this 4 by the 3 plus 6i, this complex number here, 3 plus 6i. So multiplying out the brackets, just as you would do with algebra, you do 4 times 3 and you would get 12, and then you would do 4 times 6i and you would get 24i. And that is the answer. All right, so that's very straightforward. As I said, very, very similar to algebra. But watch out for this particular example here. Let's say you had 2i bracket 3 minus 2i. Okay, so this time we have an imaginary number here, 2i, being multiplied to this complex number, 3 minus 2i. So again, we're going to multiply out the brackets as we normally would. 2i by 3 would be 6i. 2 times 3 is 6, and of course you have your I, so 6i. And now 2i times minus 2i. Well, 2 times minus 2 is a minus 4, and I times I is of course I squared. Now, where that gets different to algebra is that we're not going to leave our answer like this, because the minute you see an I squared, that of course is very significant with imaginary numbers, because one of our key things, remember, is that the square root of minus 1 is equal to I, and also the fact that I squared therefore is equal to minus 1. These are really, really important, and whenever they crop up, for example, whenever you have an I squared crop up in some sort of calculation, we are always going to want to sub in what it is equivalent to, because in this case it will evaluate to a number. I squared, of course, is minus 1, so that's what we're going to sub in. So remember what you sub in. Remember, with any sort of algebra substitution or any substitution, whatever you sub in, keep brackets around it. So we have 6i minus 4, and instead of I squared, I'm subbing in minus 1. So that leaves me with 6i and then minus 4 times minus 1, because brackets is multiplication, remember. So what's a minus 4 times minus 1? Minus by minus, of course, is plus, and 4 times 1 is 4. So we're left with the complex number 6i plus 4, which of course can be written as, we tend to always write the real first, 4 and a positive 6i is the answer. Okay, so let's take a look at this example here. So here we have the multiplication of double brackets, okay? And again, we're going to follow the same sort of approach as we would with multiplying out algebraic double brackets, okay? So that would be that you'd multiply this term by everything in the second bracket and then this term by everything in the second bracket, okay? So that would leave me to multiply 4 by 2 minus 5i, and then the positive 3i by the 2 minus 5i as well. It's useful here to rewrite that out clearly before you start multiplying. So 4 times 2 is 8. 4 times a minus 5i is, of course, a minus 20i. 3i times 2 is, of course, 6i. And 3i times minus 5i. Watch out here for signs. We have a couple of things to consider. A plus 3 by a minus 5 is minus 15. And I times I, of course, is I squared. Now immediately, if you see an I squared, what should be coming to mind is that has to be replaced by minus 1. In other words, we're going to sub in minus 1 for that I squared. So I end up with 8 minus 20i plus 6i minus 15. And then, of course, in brackets, I'm subbing in my minus 1. So that then gives me 8 minus 20i plus 6i minus 15 by minus 1 is a plus 15. And now we can tidy up our answer. So in other words, we can add together to simplify this up. And remember, with adding and subtracting with algebra, we can add the real with the real. And the imaginary with the imaginary. Okay, so what do we have? We have an 8 plus 15, which of course is 23, and minus 20i plus 6i, minus 20 plus 6 is minus 14. Don't forget the I. So 23 minus 14i is the answer. Okay, let's have a look at this question. This is our final example here. And this one is a multiplication question, but look how it's asked in a different way. So again, we're labeling our complex numbers. That's quite common. And you're asked then to find Z1, Z2, but the two of those are written side by side. And remember, with algebra, any letters that are written side by side, it's always implied that they're multiplied. For example, AB is of course the same as A times B. Or XY is of course the same as X times Y. Well, here the Z1 with the Z2 written side by side implies Z1 times Z2. So that's what they're asking me to do. They're asking me to multiply this complex number by this complex number. So remember to put your brackets. We're putting these side by side. And of course, the minute you sub it in like that with the brackets side by side, you can spot straight away we've got the double brackets here. Okay, so that means we're multiplying minus 2 by everything in the second bracket and the plus 4i by everything in the second bracket. Pause the video if you feel confident with this. Otherwise, watch and we'll go through. So it's minus 2 times everything in the second bracket and the positive 4i by everything in the second bracket. Okay, so let's multiply this out. Minus 2 by 6 is minus 12. Minus 2 times minus 3i. A minus by a minus, of course, is plus. 2 times 3i is 6i. 4i times 6 is a positive 24i. And plus 4i times minus 3i. Well, a plus by a minus is a minus. 4 times 3 is 12. And I times I is I squared. Now, immediately we see we have an I squared. And we know we've got to substitute in minus 1 straight away when we see that. So minus 12 plus 6i plus 24i minus 12, and in brackets then sub in your minus 1. So that gives me minus 12 plus 6i plus 24i, and minus 12 by minus 1 is of course plus 12. So now let's tidy up our answer and we can do our real numbers together, which is the minus 12 and plus 12. And we can do our imaginary numbers together, which is a positive 6i and a positive 24i. Okay, so minus 12 plus 12 is of course 0, and plus 6i plus 24i is a plus 30i. And that's my answer.